Okay, so we left off talking about constraints. We entered the two constraints that restricted us to the first quadrant. Remember how to read this. This says x is greater than or equal to 0. That's how you read it. But what it says is that x is going to be positive numbers only. Positive numbers are 0. And y is only going to be positive numbers. So we're putting everything in the first quadrant. Now, I keep forgetting which one is tickets and which one is meals. So I wanted to show you real quick. If I go to settings, I can add a label to the x-axis and I can say right here that this is tickets. And on the y-axis, it's meals. I don't think I have an option on where to place it. But I don't have to have that go all the way out to 60. I really don't need it to go much further than 30. That puts tickets a little bit closer. So anyway, I want to remind you that what this shaded section represents are all of the ordered pairs that are considered reasonable purchases for Roy to stay within his budget. Okay, so this point right here, let me plot a point real quick. The point, let's say 4 comma 10. There's the point 410. 410 is in the shaded section, so he can buy 4 shows. He can go see 4 shows and he can eat 10 meals in the 5 days that he's there. Okay, so he is going to have a couple of more constraints. So let's say that Roy went to Google and looked at the calendar for the 5 days that he was there, and of those 5 days, there are only 10 shows that he would even consider seeing. So that just restricted my graph over here a little bit more. So here's the number of tickets. He doesn't need to consider these purchasing options because there's only 10 shows that he wants to see. So he already knows he's not going to buy more than 10 tickets. So what he's going to do is unshade this section right here because he doesn't want to buy that many tickets. So we have restricted our graph a little bit, even a little bit more. So it makes sense to say that, okay, but how do we write that? Roy found that he only found 10 shows that he would like to see. Okay, again, remember, tickets is on the x-axis here. So when we write our equation or our statement, it needs to involve a ticket, which when we get to Desmos, we'll have to change it to x's. So if he only found 10 shows, then how many tickets is he going to need? The number of tickets that he's going to need compared to 10. Is the number of tickets that he's going to need going to be less than 10 or greater than 10 or equal to 10 or what? Well, it's going to be less than because he may not go to all 10 of them. Just depends on what time they're being offered, if they're sold out or not. Those are some things that would, help him decide how many of those he's going to see. Could he see all 10? Yes, he could see all 10. So this is another restriction that we're going to go over here and put. And so basically, we're going to be restricting the graph to cut off those portions of those reasonable or feasible combinations that we don't need. So we want this part right here to go away because he's not going to buy 11 tickets, 12 tickets, 13 tickets. So we're going to go back up here and do just like we did a while ago. We're going to put this and we're going to say the number of tickets that's on the x-axis, and it's going to be less than or equal to because he might do all 10. And Desmos cuts off this part over here and says, okay, so since he's not going to see any more than 10 tickets, we're only going to be looking at this region. All right. And then we've got one more thing to consider. And the other thing to consider is Roy knows he's only going to be there 5 days. That was in the original problem. Roy knows that he will only eat 2 or 3 meals each day. So he's given us an option. If he's there for 5 days, and remember, This is in the information, I think, on page 17. He's there for 5 days. If all 5 of those days he eats 2 meals, that's 10 meals. Or if all 5 of those days he eats 3 meals, 3 times 5, that's 15. Now, we don't know if that he's going to do 2 meals a day for all 5 days or 3 meals a day for all 5 days, but these are the two extremes. Okay, it can't be lower than 10 and it can't be bigger than 15. So we're talking about meals, and meals this time is on the y-axis. So when I write my constraint, my mathematical statement, it's going to involve a y. And anytime you have to write a mathematical statement that involves 2 endpoints, a beginning and an end, the easiest way to write it is put your variable in the middle, put 2 less than symbols, one in front, one in back. Yes, they're always less than, and put the smallest number in the front and the biggest number in the back. And now it reads exactly what it looks like. The number of meals is between 10 and 15. If we read it as if we just called words from the symbols, 10 is less than y is less than 15. That's how it would read, but what that says is that y is going to be some number between 10 and 15. Now, should we include the bar underneath it? Well, can he eat just 10 meals? Yes, he can. Can he eat 15 meals? Yes, he can. So we're going to include the bars underneath them. So now we're going to go over here to the meals, and what that's going to look like is we're going to go over here. Okay, here's the bottom number right here. Here's the 10. And then here's the 15 right here. So what that means is this. We now no longer want this section right here. This section's going to be excluded, and this section up here is going to be excluded because it's too many meals. So the only feasible, under these constraints, the only feasible ticket and meal combinations that will work with his budget of 1,360 are any of those points in there. Okay, so any of these points in here would be reasonable ticket and meal combinations given all of these constraints. Well, guess what? We're going to go over to Desmos and we're going to enter that one more constraint that we had. We're going to enter the brace and we're going to say 10 is less than or equal to, y is less than or equal to 15. And now we find out that that dot that I picked a while ago is just barely still in that region, but it still counts. And the reason that we know it still counts is because we said we could include 10 meals. Remember, this is 4 tickets and 10 meals. And so we have the bar underneath the 10. If we didn't have the bar underneath the 10, I believe it would be dotted. No, it didn't do it. But it didn't. Oops, what did I do? So here you would have to know the graph doesn't look differently because of with the bar without it. So you have to understand that 10 is included. Now you could definitely take away the mystery and move it up here. So if he goes to 4 shows, he can afford 11 meals. Or he could afford 12 meals, or he could afford all 15 meals. Whoop, not 115. He could afford 15 meals. So remember, this is tickets and this is meals. So any point in here would be a reasonable combination. And the restrictions that you write are just going to be based on your wording. And yes, it takes some thought. So you're just the only way to get better at this is to just do it over and over and over. So I'm going to go ahead and stop the video right here because I have no idea how long it is, but I do want to help you do a couple of more problems like the ones that you're going to see on your homework. And then I will be done with this ridiculously long lesson.